Hi there. Okay, I'm going to show you how we're going to complete the square. So, which means a process that we are going to take a standard form of a function and we're going to convert it to vertex form. So, we're going to use this concept where if you looked at the minds on section of our lesson, we had it where we had that perfect square trinomial. And when we showed that using algebra tiles, we were able to create that perfect square. We're going to just totally borrow that concept. And I'm going to show you how we're going to do that in this example here. Because in this example, this is not when we have x squared plus 6x plus 5. This is not a perfect square trinomial. It's just not possible. If it was, it would be half of 6 which would be 3, and 3 squared would be 9, and that would be the value at the end here, which it's not. It's 5. So I've modeled this with the algebra tiles, which I know you're not a huge fan of, but this really actually literally shows you what the completing the square process is like. Because I have this empty spot here, which to complete the square, and this is your x squared, we have 6 x's and we have 5 1 tiles. I want to complete this square. So I am going to do a little bit of math manipulation or math magic, however you want to look at it, to make this work. So to do that, I am going to actually finish off this square. I'm going to grab these and I'm going to need 1, 2, 3, and 4 squares. So I added 4 plus squares. So I'm going to write this down so far. So what we've done so far to let's say manipulate our situation is I have looked at this function and I have decided to add 4 1 tiles. Well, I can't just do that. I have totally changed this whole thing if I just leave it like this. But I can do one thing. I'm going to use the zero principle here, which means if I add 4 positive tiles, and in order to not actually really to affect my equation from what it originally was, I can add 4 negative 1 tiles. So I'm just going to have these out here. 2, 3, 4. And these don't have, this does not matter in out here. This kind of just hanging out here. So here we have our perfect square situation. And these guys are just kind of hanging out because, hey, they balance this out. Because these 4 here that we had balance out with these 4 that we just had here. So to do that, I'm also going to show this now here as well. So I'm going to grab my pencil here and -4. So now technically I have done no wrong here. I have completed the square. I've added 4 tiles to do that, but balanced it by also adding 4 negative tiles. Okay, well, I'm going to take advantage of the situation. Oops. And you know what? I forgot this +5 in there. So that's going to make a huge difference. So just give me 2 seconds. Let me just fix this. And I'll make sure I have a little more room anyway. So that's not a bad thing. Okay, so I'm going to write it over here. So we have f of x. The original was x squared plus 6x plus 5. Then we decided to complete this square by adding 4 1 tiles. And then to balance it, we put 4 negative tiles. Okay, and that works perfectly. So what I'm going to do now is I'm like, well, there was a reason why this is now a perfect square. It's because now if we add 5 and 4, we are going to get that 9 value. So what we're going to do is focus on this section right here. Now I'm going to simplify these two sets of 1 tiles, which are 5 and 4. So to do that, just to simplify it, I'm going to write x squared plus 6x. The 5 plus 4 gives you that 9. And then there's this -4 just kind of hanging out here, which is perfectly fine. But now I'm very stoked because I have this perfect square situation. It's like awesome. So that perfect square trinomial. So I'm actually going to factor this. It's kind of like that factoring by grouping that we've done in other situations. Okay, so I have the square root of 9, which is 3. And I'm squaring this because I'm factoring that, and then the -4. Let's test this. So if you recall, if we go backwards, square the first, so x squared would be x squared. Double the product. Well, the product of this would be 3x. Double it, you get 6x. And then square the last. 3 squared is +9. So we factored this correctly. So what we've done is we've come up with the equivalent form of this standard form, but now it's in vertex form. So x plus 3 squared minus 4, which we can now state the vertex being -3 and -4. All right, so hopefully you can see how this process works with that we're literally completing the square in order to do a little math manipulation, little math magic to now get it into vertex form from standard form.